We were for absolute beginners, number 4. This is a direct continuation from number 3, which is an absolute prerequisite. So we're looking at Advent of Code 2018, Problem 1, Part B, which requires you to find the first repetition in a long list of numbers. It's easy to generate the list of numbers. Well, actually, that's actually kind of the thing. It's not easy to generate the long list of numbers in Uiua. Let's take a quick look at where we were. So here's, I've got a read-ins function. I've got a min-by function I'm going to use later, a modifier. I've read the data, but now I've just changed it to some sample data, and here's a solution for that problem 2, and it gives us the answer 5, and that's good. If I comment this out, then it doesn't work. Cannot take the first value of an empty array. It hasn't found a repetition yet. I'm asking for the first of a where, and the where is giving us an empty array because it can't find a 1. There's no repetition. That's because I haven't taken enough of these things. What if I take 100? Okay, still, like 100 repetitions is not enough. And I could obviously just add a 0, maybe 1,000 will be enough. There we go. Okay, 1,000 repetitions was enough, but this is not an elegant solution. It's not a general solution. It's it's interacting with the data, and there's a time and a place for that. But if all I want is a solution, I'll use another language because it's a lot easier. But I want a good Uiua solution, and this is a bit of a rabbit hole. So hopefully it's a rabbit hole that you find appealing. I'll just say at the outset, experienced programmers will no doubt find a simple one-line way to get this done in Uiua, and I'd love to learn from that. I've never written any kind of looping construct in Uiua. I don't know anything about it. I know that there is an if that you can use. It's a question mark. I've never used it. There used to be recursion, and I thought maybe I could do a recursive solution. Didn't think through the details, but I thought you can use recursion as a looping construct, but recur has been taken out of the language. Okay, I need to stress Uiua is a moving target. It's not stable. Its website makes no bones about that, and it's actually really fun to see the things that come and go from the language. It's being very, very well curated. Okay, so I want a different solution. I'm taking a very different approach. I'll just point out too that there's something better about my solution. So even if I could get this working in Uiua, like to work out how to keep iterating as long as you need without knowing in advance how long to make it, you would still be chewing brute force through a lot of data. And the approach that I'm going to show you doesn't do that at all. It takes one look at the data, does some calculations, and forms the answer. Okay, but it's much harder to understand. It took me a lot of pen and paper work to get anywhere with this, and a lot of experimenting, and this is good. It's how you learn. All right, so we've got sample data here, and we've seen this before. It looks better. It's easier to think about if you put it in an ordered way, right? So here's our original plus scan, and then as you keep generating more and more frequencies, put them in these columns, right? And there's an observation to make that the rows here increase by 4 because the first frequency is 0. Now where's 0? I'm leaving it out because it doesn't fit my shape very nicely. So anyway, the frequencies begin at 0. And if you go through one cycle and end up at 4, well, then that means the next one's going to end at 8 because it's like the next one begins at 4, goes through exactly the same deltas. So of course it's going to end at 8. Then the next one's going to end at 12. So there's a real pattern in these columns. They go up by 4, right? And that means that there's actually some predictability here. So here's our 5, and there's the 5 that gets repeated. Why does 5 get repeated? Well, because there's a -3 here. And if you go up by 4, then you go 1 and then -5. Okay, so one approach to this problem could be to say, all right, if I'm going to get a repetition, then well, I can convince myself that the repetition is going to be one of these numbers. Don't know which one, but it's going to be one of these numbers, right? And you can say, well, what numbers do we get in this column? What numbers do we get in this column? Oh, look, it's one of those. That could be one approach. It's not the approach taken here. Okay, so here's the thing. If everything's going up by 4, then modulo 4 is a relevant thing. And so this column, everything here has a residue of 2. Everything is 2 more than a multiple of 4. Everything here has a residue 1. Everything here has a residue 1. Everything here has residue 2. Everything here has residue 0. So you'll see that there are 2 columns of residue 1, and there's a 5 that occurs there and a 5 that occurs there. A 5 is never going to occur here or here or here. It just can't happen. Here's a 10 and it gets repeated later, right? But it can't be repeated in the same column because it's increasing, right? And of course, with a different data set, this could be decreasing. It doesn't matter, but it's not increasing and decreasing. You can't ever come back to 10. So if you're ever going to get a 10, it has to come from another column that has a residue 2, and here you go. And it's entirely predictable that a 10 will occur in this column because it starts at -6, which is smaller than 10, and it goes up by 4. So eventually you'll get to a 10, and you can calculate how many steps are needed to get there. So there are 2 primary repetitions here. Once you get 1 repetition, you get many more. You can see here 5, 9, 13, 17, and 5, 9, 13, 17. Okay, so those are uninteresting repetitions. But yeah, we care very much about the residue modulo 4. So there's just like in writing what I just told you. Now, it's really important that there will never be a repetition of any of these numbers, 4, 8, 12, 16, 20, because there's no other column that's got a residue of 0. So what we need to do is we need to take our plus scan data and we need to group them by their residue modulo 4 so that we can do analysis. Right, so here's an informal data flow, kind of like a Uiua stack, but not meant to be exactly like it. So here's our data, here's our plus scan. We take the last value 4 because that's our modulus. We calculate this modulo 4 and we get the familiar 21120. Then I group them, so I group these according to this, right? So Uiua has a function called group, which is very cool. And so we'll put the -6 and 10 together because they have the same residue. And we'll put the -3 and 5 together because they have the same residue. And the 4 gets its own group because it doesn't have anyone to dance with. And so our next step will be to discard the 4. We only care about groups that have at least 2 things in them. All right, so we'll discard them. We'll calculate the gaps. There's a gap here of 8 and a gap of 16. If you select the minimum gap, then we'll get the -3 and 5. You make sure they're sorted. In my early experiments, I sorted this early on so that everything here would automatically be sorted. Turned out not to be a great idea, but as long as these are sorted, right, then means that -3 is the number that occurred in the original and 5 is the number that occurred later. Now I'm starting to wonder, is that actually true for every possible data set? But I'm not going to agonize over it now. So we've got our group that contains the answer, and then we just pluck the answer 5 out of there. Okay, now here, because I'm working with a small sample data, it's kind of fallen out nicely. But with a large data set, there could be, and you'd expect there probably would be, many groups that have the same gap size. There could be 3 groups with a gap of 8, and 7 groups with a gap of 16, and 8 groups with a gap of 20, and 1 group with a gap of 24, and whatever. So then you'd have to look at, okay, I've got 3 groups with a gap of 8. Which one of these contains the first repetition? So you need to kind of go back to your original thing and see like what came first. Okay, so hopefully that gives an insight into the approach. When I'm doing this in Uiua, all I can really do is execute the approach. I can't keep explaining the approach. So with, after a lot of coding trial and error, I thought, all right, it'd be good to have a function that finds the smallest gap pairs. So we give the plus scan of the data, right? The original data is not that important for us. It's the plus scan of the data because that's the frequencies, right? We don't care about the deltas, we care about the frequencies. So we give it this, and it gives back, let's say, a 2-column matrix of all of the pairs, right? There's only one minimum pair here, but like it does all of the smallest gap pairs, does all this work of doing finding the modulus and applying the modulus and putting them in groups and discarding any that are too small, and then choosing the ones that have the minimum gap. Okay, once we have all the minimum pairs, right, I'll say it one more time, probably the last time. In this sample data, we only had one minimum pair. Okay, and I got excited and I thought, oh, cool, I'll take the minimum pair and I've got the answer. But there can be more than one minimum pair, okay? I didn't really want to go making up larger data for myself. That's like a really wise thing to do, but I thought you have to be careful in the creation of this data, and I just couldn't be bothered. So we need to, for all AB in the smallest gap pair, so here's our A, here's our B, here's our A, B, right? We find the A that occurs earliest in the input in here. So -3 has an index of 1 in here. And if there was like a 10 down here, then that would have an index of 3. So we would take this one, right? So we take the value that has the smallest index in our original data, our plus scan data, and then we take the 5 because that's what goes with it, and that's our answer. What about 0? I'm ignoring 0, and that for certain data, maybe that could bite me, I'm not sure. We start at 0 as a frequency. Could we ever get a 0 frequency again? I think with a little bit more mathematical analysis, you could get an answer to that. I'm just ignoring the problem here, right? So I'm trying to do a general solution, but a student of mine gave me this code, which is, I was going to talk more at length about it, but this is a similar approach to what I showed in the last video. Okay, so let's get in with some coding. All right, just look at my notes. So I'll maybe get rid of. No, I'll keep this data because we want to see results as we go through. We'll comment that out, and that for now. All right, so we've got our data. Let's take a plus scan of the data. All right, so there we go. I'll get rid of this part 2. We don't need that. All right, we've got our data, our sample data. Take a plus scan of the data, and now we want the last value to use as our last modulus, as our modulus. So the last value is the first of the reverse, and we want to work on a copy. All right, I'd really like it if there was a primitive for last, but there's not. So the first of the reverse. So now on the stack we've got our modulus, and it's easy to now apply the modulus. Okay, but we've destroyed our original, right? So now just looking at my notes actually go back even further where I did sort the original away. I don't really want that. So I'm going to, I want to preserve, now let's just see, I've got that. I want to preserve the original array. I want to calculate the modulus. Now, how do I preserve the original array? Like, if I go mod, that destroys that. I can't go mod of that. That doesn't work very well. Normally, when I want to preserve something, just put a dot to duplicate the top of the stack. one thing I can do, and I think that's all I am going to do, is to do dip dot, right? That has, like, dip is like take a dive into the pool, right? Go one level deeper into the stack and then apply it. So I'm going to duplicating the second last thing. And so now I can do mod. If you look at the stack, I can do mod 4 of that, and I've still got a copy of the original. Okay, there's probably another approach, maybe a better approach, but actually I quite like that one. All right, I'm going to group the sorted array by residue. So if I type group, what happens if I do group here? Okay, so I know from experimenting, right, and maybe reading documentation or whatever, I know from experimenting that I need to go group box. So group, you can see from the coloring that it's a modifier, and so it needs a function, and I'm going to do group box. Okay, so geez, that worked very well. So I'll take a dot so that I've still got the originals to look at. Oh, no, that destroyed it. Oh dear. All right, so I've got a group. So that's put them in residue groups, like -6 and 10 belong together, -3 and 5 belong together, and 4. Okay, so I think I'm just going to put another dot here so that we've still got that. Okay, so group box, you can see that it's put them in boxes. I guess you can use a different function here to get different things. Oh, I guess it would be, for example, let's just say I group plus. No, okay. All right. I'll stop freelancing and get back in my box. All right. And now I'm going to remove anything that's got too few elements. So I'm going to say each and greater one there. No, that's not the length. Length. Okay, take a dot. Right, so here's our groups, and for each group I'm applying this function. Between the brackets is a function, and greater than 1, think of that as a function to say, is the following thing greater than 1? Okay, so is the length greater than 1? And you can see here it's given a 0 for that one, and a 1 for that, and a 1 for that. And so now I'm going to use the function keep to say I'm going to keep 0 copies of that, I'm going to keep 1 copy of that, and I'm going to keep 1 copy of that. All right. Now the documentation in Uiua it's such a wonderful web page. It explains why this is an upside down triangle. It's because the function keep is most often used as a filter, which is exactly what I've done here. I've filtered the ones that I want, and the upside down triangle looks a bit like a coffee filter. So it's very playful, and it actually does help you remember, and I also love filtered coffee. So, all right, now to solve this problem, right, we only want 2 of each. I just need to look ahead and think there could be more things. I only want 2 of them, and I want them sorted. So I'm going to say I just want two of each, thank you. So I'm going to say, I'm going to call each and say, just give me 2, please. So I'm going to say, take 2 of the unboxed version. There we go. All right, so it's given me a matrix now, -3 and 5 and -6 and 10. And I kind of want them sorted. I've got this funny feeling that I've mentioned before that sorting could be dangerous, because what if the data took you down instead of up? So I'm a bit scared, but I think my solution relies on it. Or should I try it without it? Okay, I'll try it without it. And now because I've got a min by thing, I can say, give me a minimum by the smallest gap, right? Or let me say I'm going to do each, and I'm going to do a minus reduction. So the answer here, that 5 minus negative 3 is 8, and 10 minus negative 6 is 16. So you can see, right? Oh, that didn't do anything. Do I need to do row here? Yeah, that makes sense because I actually have a matrix now. Okay, so here's my matrix, and here's the values 8 and 16, like I thought, right? But instead of actually putting these values on the stack, instead of the modifier called row, I could use the modifier called min by, and that gives me the negative 3 and the 5. Oh, how cool is that? And then if I get the last value of that, or in other words, the first of the reverse, then I get the 5. So that gives me the correct answer for this data. And now if I comment out the thing where I use sample data and instead use the real data, then it gives me an answer, right? It shows me some working too, because I've left a few more dots here than I need, but that's not the correct answer. And that, as I explained before, if we have like smallest gaps in that, there can be multiple smallest gaps, but we need to get the one that occurs first here. So I need to do a bit more work. But anyway, that's pretty cool so far. All right, so what I'm going to do now is say, well, I'm going to take this idea and put it into a function, right? So the smallest gap pairs, it is a function where we do the, now I'm not going to do the plus scan, that'll be done first because we're going to operate on the plus scan. So we're doing the first reverse dot, once again, and I should be checking as I go. So the smallest gap pairs of the plus reduce of the data, and I do want to work on the sample data now. All right, so I should don't really want to see. What I'll do is put a separator. There we go, 3 separators so we know where to look over here. Right, so the smallest gap pairs of data. All right, so far, so good. All right, let me reformat this again. Right, we've got our modulus. We do the dip that to so that we get the copy that we need where we need it, and we take the modulus. Okay, and then we do the group using box as our function, and then we remove the singletons. So how do we remove singletons? We'll say each, and we apply the function. Is it greater than 1? Is what greater than 1? Is the length greater than 1? Okay, and I need a dot because I don't want to consume the group. I want the group still to be there. And then I do a keep. So I'm going to put the keep on the same line because this is an idiom, right? So the keep over the each of the function is like filtering the function. You keep each one that obeys this rule. So in development, I was doing it one bit at a time to explain it really bit by bit, and here putting related things together. Okay, so we only want the smallest 2 of each group. So we do the row. Row and each work the same when the data is kind of flat. I kind of use row more than each. When I get more experience, I'll know more about the difference and when to use each one. So I'm going to take 2 of the unbox. Okay, and if I want to sort them, then here's the place to do it. So unbox and then select rise dot. Okay, so that sorts each one as we go, right? And keep that in. So you can have quite a complicated function between the brackets to apply to each row. Okay, so that's sorted as well. And then we're going to find all of the groups. Now, I'm not going to do min by this time. I'm finding all of the groups that have the smallest gap. So what do I do? I say row, and so for each row, I want to calculate the gap, and I don't want to consume what I've got there. So I've got the 8 and the 16, right? And now I'm going to find the minimum of those. So reduce the minimum, and so the answer is 8. And what I'm going to do now is I'm going to call find, right? Which is going to find. Okay, right. So I need to keep a dot here. Let's look at the stack, right? So the minimum is 8, and I need to go, right, where is 8 in here? So I'm going to say I'm going to find it, right? And here's a really cool, that's a magnifying glass, and I'm finding it like it's 1 and 0. So it's, the find is like, I don't know, it's like saying equals 8 or something. Okay, no, I'll stop freelancing. All right, so we're going to find, and then I want to do, right, a where. So where is it equal to 1? It's equal to 1 at index 0, but you can see it's in a list here. It could have been equal, it could have, been a match in many places. And then I'm going to select, not pick, I'm selecting because I'm selecting multiple things. And so that gives me the 3, 5. Okay. Now, so this is not my solution yet, but it's the smallest gap pairs. And now instead of having the sample data, I could have the real data and see if smallest gap pairs works. And there we go. There's a lot of, right? There's a lot of pairs, right? And if I just sort of do a quick check to see, do they have the same sort of gap? If I go get my calculator and type 82709 minus negative 645, that's a gap of 83,354. And if I just take the one down the bottom of the screen, so I go 82762 minus negative 592, that's 83,354. Okay, so just a little sanity check, but of course it should work. But it just goes to show that the real data is much harder to work, with than the sample data. Okay, so I've got the smallest gap pairs, right? And I could collapse that into fewer lines maybe, but I'm not going to right now. All right, so now I've got, like, how do I turn this into a solution? So I'm going to go through just a little bit of like development here, a little bit of educational development, like exploration. This is exploration I had to do myself. So I'm going to create a little sample list of 5, 2, 3, 8, 7, 1, 6, 9, and 4. And I'm going to have some pairs that, like 4 and 25, 8 and 29, 1 and 26, 2 and 23, and 7 and 28. These are all equal gaps, right? Now we're going to stop looking at that. Okay, I think now I'll just delete that. All right, and okay. These are all equal. Well, let me put them on the stack so we can see them. So I've got a list and I've got some pairs, right? So the list is like my frequencies, and these are some smallest gap pairs. They all have the same gap. That's not necessary, but what I'm doing here is going, right, I've got these smallest gap pairs. How do I find which of these occurs first in there? Now with our human eye, we can see 4 occurs there, 8 is there, that's pretty good, 1 is there, 8's still the best, 2 is there, oh, hard to beat that, and 7 is here. Okay, so what we're really after here is 223, and then get the rightmost one to get the answer 23. So that's what we're trying to, like the challenge now, given that list and that matrix, how can we extract that? Because that's the earliest in there, right? Not, as they say on YouTube, why don't you pause the video and try it yourself? But it's not easy for a beginner. I'd love to be better. All right, so let's go bit by bit. So I'm going to take the firsts is the row first pairs. Okay, so so there's our 4, 8, 1, 2, 7. Right, so I've got those. And now I'm going to say, okay, where are the indices? The indices that I need is, I'll go index of the firsts in the list, right? So I'm not putting the pressure on myself here to work with the stack. I'm working with names, and I'll convert it into stack code later. So I want, these are numbers that I want to find in here, and I want to know what the indices are. So I want to jump over that, right? Okay, here we go. And this is a problem. You need to actually explicitly put it on the stack. It's fair enough. Okay, so 8, 3, 5, 1, 4. And I went through it before, like the 4 was here, that's at index 8. The 8 was here, that's at index 3. And then we've got index 5, index 1. Right, the one we want is 2. It's at index 1. All right, and now what? Well, I'm going to join the indices with the pairs. Now this isn't going to work very well, like didn't work very well at all, right? I need to do a row. I've got a row, and I'm going to join the indices with the pairs. And that gives me the 8, 3, 5, 1, 4 along with those, right? And so the join is working pairwise. It's like join the 8 with the 425, and then join the 3 with the 829, that sort of thing. All right, and so now what I'm looking for is the minimum of these. And so I can actually call min by here. Min by what? Or is it just the minimum? No, it's minimum by the first. And that gives me the 1, 2, 23. All right, so if I put a dot there, we can see 1, 2, 23, and min by first has given me that, right? And then with that, I can just take the last, and I get 23. Okay, so that, if I've got the list and I've got the pairs, then here is some inelegant code that can brutalize that into the actual answer. And so now I need to go, right, how do I do this in a more stack-based way? So I'll oops. Okay, so let's start with the list and the pairs again. Right, and we want the first of each pair. So that's row first dot. Okay, we want those. And now, like, what did I do then? I did the indices of the firsts with the list. So I need the indices of that with that, right? But the stack's out of order. I need to promote this one up the stack. And so what I can do, like colon, just swaps the top two elements of the stack. You can see there, if I do a colon again, like swap them back, okay? But I don't want to swap items 1 and 2. I want to swap items 2 and 3. So what I'm going to do is a dip colon. And now that's put the stack in order, which means I can find the index of that into that, right? So I can go index of. All right, good. Do I need a dot? What do I do now? I've got my indices, and now I need to do a row join indices pairs. Well, everything's actually there. I need to join that with that, so it's beautiful. So I'll just go row join. There we go. And now I can do the min by. So the rest is all good now. The min by the first, and the okay, and we get 23, right? And so what I'm going to do now, so that's better, and so I'm going to have, say, solution, have a function for solution. Okay, so solution, we're going to take the advent of code input, so that's an integer list. I'm not going to do the text, and it's going to output the answer. Okay, so that's going to take that, right? So what's the solution going to do? Well, it's going to do the scan reduction. It's going to do the smallest gap pairs. Oops. Okay, and that needs to work on a copy of it. That's an interesting, I've got this code here. Yeah, I think there might be a bug in the formatter. The formatter just destroyed my code. Okay. Smallest gap pairs, and then we've got the okay, and if I call solution on my now actual data, yes, that's right. Damn it. All right, so what does my data look like? Oh, too big. Oh, it's no, the format is definitely being funny. It's not good. Oh yes, okay, back to our normal data. So if I call solution on data, right, then I get all right, okay, so no, I've got to say I'm confused. This is probably my own fault. Oh, I've just got this out of order. Okay, so solution, the first thing it does is a plus reduction, then it applies smallest gap pairs. So we've got the 3 and the 5, right? And I might just, I'll just do a copy of this. Okay, so, and if I have that, then, all right, smallest gap pairs is working, right? And now, smallest gap pairs of that, right? So, and then I'll do the row first of a copy, right? So, no, this code's being destroyed. Sad. Okay, well, I don't think I'll beat that dead horse any longer. So what we'll do, this is going to be just a solution, right? And instead of the list, I'm going to have my my plus scan of the data, and instead of pairs, I'm going to call smallest gap pairs, right? And Right, and there we go. So below the separator, our answer's 5. And if I comment that out, so we're dealing with real data, then we get the answer 83,130. I won't show you my Advent of Code page, but take my word for it, that is the correct answer for my data. So sorry for the the mucking around at the end there, but there we go. I've got a function that I'll get rid of this. Okay, I've got a function that gets all of the smallest gap pairs. I do a plus scan of the data. I find the smallest gap pairs, then do a bit of jiggery pokery that finds where that lines up with the earliest thing in the original data, and we get it. Okay, so it's a nice solution. I'm sure other people can make nicer ones, and I'd like to learn from them. All right, see you later. Oh, by the way, this will be the last of these videos for a while. Too many other things to do. Okay, have fun.